Hello guys, today we are going to solve Putnam 1988 problem number A1. The problem stated that let R be the region consisting of the points xy. Obviously this R is not denoting real numbers over here, just I have written like that. That let R be the region consisting of the points x, y of the Cartesian plane satisfying both of these equations, or better say inequations. Mod of x minus mod of y less than equal to 1 and mod of y is less than equal to 1. This is and. What we have to do is sketch and find the area of that sketch, uh, which will which we are going to draw over here. Before starting the solution, please don't forget to subscribe my channel if you want more such videos, and like and share this video if you like, and comment all your valuable suggestions. So let's start the solution. Obviously we have been given with two inequations, so we are and question has already stated that sketch, so obviously the key point is going to be drawing the graph. So let's start with it. I am observing here mod with x as well as y. So let's start by plotting the x and y axis. So I have made x and y axis. Here is positive and this is positive, then this is negative and this is negative, x axis and y axis as convenient. So let's start. In this quadrant, that is first quadrant, we can write it as, because mod x can be written as x and y, mod of y can be written as y less than equal to 1. So let's make graph of x minus y equals to 1. So I am going to make a graph of x minus y equals to 1, then see which part of the line will satisfy this inequality. So let's draw. This can be written as y equals to x minus 1. Obviously, slope is positive and then the intercept is minus 1. So this graph is something coming to be like this. And obviously, this is true for only first quadrant. So I will select this part of the graph, which goes to infinity. Okay. Now let's come to the second quadrant. In the second quadrant, x lies on the negative x-axis. So mod of x will be written as minus x, whereas mod of y will be written as only y, and it is less than equal to 1. Better say x plus y plus 1 is greater than equal to 1. So, sorry, 0. Now let's make the graph of x plus y plus 1 equals to 0. And how we will draw is x plus y plus 1 equals to 0, which is also equals to minus 1. So this graph will be with negative slope, and that is will be minus 1, and with intercepts minus 1 on x and y axis. So something like this, from it will start from here and with negative slope. So I will draw it like this. And obviously this graph is only for the second quadrant, so I am taking this part. Similarly, if you will solve this for the third quadrant, that is because mod x will turn out to be minus x, then mod of y will give you also minus y less than equal to 1. And when you will draw, so let's start, let's solve this for what we will get. Y minus x less than equal to 1, and then this will be y is less than equal to x plus 1. Or let's draw y equals to x plus 1. What we will get is, it will be something like, because here something will be 1, so its graph will be looking like this. But as we know that we have to take in the third quadrant, so just the graph we are going to take will be this part, and we will ignore this part. And similarly, when we will solve for fourth quadrant, we will get this part. Okay, this will be parallel to this. So we have drawn the graph of mod of x minus mod of y less than equal to 1. This is the graph, which is the blue solid line. Okay. Now let's draw the graph of mod of y less than equal to 1. Mod of y, because this I had demarcated as 0 comma 1, and this was 0 comma minus 1, because when we are plotting the graph, it was in my mind, and this was 1 comma 0, and this was minus 1 comma 0. So now, because here it is 0 comma mod of y less than equal to 1, and here y coordinate is 1, and here minus 1, mod of y will turn out to be 1, and the region between these two lines, I am drawing those two lines. Okay, now the for the region between these two lines, from this, the value of mod of y will be less than equal to 1. So just we had to find what common area, and the common area can be easily observed as this is the common region which I am shading here. This is the common region. So the shading part is done. We can clearly observe that if I carefully observe this trapezium, if I calculate the area of this trapezium, by similarity we can say that all other three trapeziums area will be separately equal to the area of this trapezium itself. So let's calculate the area of this trapezium. When you will solve y equals to 1 and y equals to x minus 1, then you will get that this coordinate is 2 comma 1. So we can get this length is going to be 2 and this smaller length is going to be 1, because we know that this is 1 comma 0. Similarly, this height we are going to get because it's y equals to 1 and this y equals to 0, so this is 1. So also we know that area of this trapezium will be half into sum of parallel sides, that is 1 plus 2, into area of, this is area of one trapezium, into the distance between the parallel sides, which is 1. So it will turn out to be 3 by 2. Now area of this whole shaded region will be, required area will be 4 times this trapezium's area, and this trapezium's area is nothing but 3 by 2. So 2 2s are, and this is 6. So this is our required area, square units. This we must write. So this is the area for this required region. Hope you like the solution. If you like the solution, then please like the solution of this question and subscribe to my channel for more such videos. Thanks for watching.